guys. So, lesson 1-6. Try this again. Graphical transformations. Stuff that technically we went over back in Algebra 2. Okay, my Algebra 2 kids this year are already going through it. We keep revisiting it, so we're going to revisit again. A few tweaks and stuff on things this year, a little bit higher level thinking on some of it, but a lot of it stays the same. So, horizontal translations. What do you remember about when we move left or right?
It's opposite. So you're going left, it's adding. If you're going right, it's subtracting.
Okay. It's opposite the sign. Okay. And where do you find that left or right translation? It's usually in parentheses, under the square root, within the absolute value. It's there with the x, somehow stuck together with the x. So if it's minus c, it's right c. If it's plus c, it's left c. Vertical translations. So how do we know when we go up or down? Yeah, it's more on the outside. It's not in the radical or in the absolute value or in the parentheses. It's at the end. Plus says we go up. Minus says we go down. Those are old news, right? Hopefully we have those. We did those enough last year. Reflections. Two of these reflections are ones we had last year. Another one is a new one. So, based on f of x, if you have a negative f of x, so that means if you take a negative and multiply it by the whole equation, then we're going to reflect across the x-axis. If it's f of negative x, where you take negative and put it in place of x, negative x in place of x, it's going to reflect across the y-axis. And then we've talked about the origin, but this is new in terms of looking at the equation. If there's a negative multiplied by the whole equation and a negative on the x, that is through the origin. Which, if you think about it, that is combining the x-axis and the y-axis reflections, yes? And how do I usually describe when we talked about, where did we have symmetric across the origin? Where have we talked about that? Not even. Odd. If something is odd, it's symmetric across the origin. And how do I usually describe that? I usually say, take like a quadrant part of it, reflect it across the x and the y. So do two reflections. And there's kind of the algebraic support. Okay? Now, stretches and shrinks. I feel like the Algebra 2 book, instead of saying shrinks, uses compressions. I'm trying to remember.
It was stretching and compress. Yeah.
Was it stretch and compress? I have compressions written down here and in parentheses, which is why I was trying to. So shrink is another way to say compressions. And I believe compressions is what was in the Algebra 2 book. You would think I would know. I just have taught it. But in my mind, compression and shrink are the same, so I don't necessarily, separate those too much in my brain. Now, stretches and shrink section is a little bit different. The stretch and shrink section we had last year is this bottom part. This should look familiar, right? Whereas y equals c times f of x. I think our algebra notes used a. But when you multiply by a number out front, if you multiply by a number that is greater than 1, then it's going to be a stretch. If you multiply by a number that is less than 1, or what we will sometimes say as 0, less than c, less than 1, meaning it's a number between 0 and 1, then that is a shrink. So it's pushing down. Now, these are the ones we did last year, and these are the vertical. Okay? This right here are the vertical shrink and stretch. So you'll notice when I talked about last year, when I talked about these, a vertical or a stretch, when we talk vertical, means you're stretching it up. When it's a vertical shrink, it's going to push it down. Okay, this top part up here, y equals f of x over c, this is new. We didn't have stretches and shrinks in this form. And these are the horizontal. Okay, these are the horizontal stretches and shrinks. And the idea of horizontal, it's a little bit different because this says if x is divided by a value. Okay, if x is divided by a value and that value is greater than 1, it's a horizontal stretch. Now think, what does a horizontal stretch mean? That means if I'm horizontally stretching something, I'm taking it and making it wider. Okay? And then a horizontal shrink says if I shrink by a factor of c less than 1, which again, same thing where c is between 0 and 1, a horizontal shrink means I'm going to take it and shrink it in horizontally. Now, you will notice a connection, we'll talk about it, that if I'm vertically stretching something, what does it tend to do? As it gets taller, it appears skinnier, right? Well, a vertical stretch and a horizontal shrink are essentially the same thing. Okay? It's just a matter of how it's expressed. Same thing with a vertical shrink. When we talked about vertical shrink, we said, okay, it's kind of squishing it down. Well, as it's squishing it down, it appears to be wider. And that is your horizontal stretch. So when we get to that, we'll talk about the connections there. Okay? Now, keynote here. Transformations can be performed in succession, so one after another, if the transformation involves stretches, shrinks, or reflections. The order in which the transformations are performed may make a difference. Okay, so in those cases, we want to pay close attention to order. And I tend to try and look at it as, okay, what's being done to X first? Okay, and I can't say that will always work, but what's being done to X first, and that will kind of determine which transformation do I do first. Okay, let's look at a few of these. Example 1 is about vertical translations. Kind of gives it away there, but describe how the graph, actually this should not say just vertical. This section is horizontal and vertical translations. Describe how the graph of y equals absolute value of x can be transformed to the graph of the given equation. So y equals absolute value x is what I would call the parent function, if you remember that terminology, what the basic function is. Thoughts on y equals absolute value of x minus 4. And we're being asked to describe. Yes, Carolyn? Okay. Since that minus 4 is outside the absolute value, it's the up or down with the direction of the sign, so this is going to be a down 4. Now, use some kind of verb there. Translates is our official verb. Shift works as well. Don't just tell me down 4, please. Okay? Give me some kind of verb there. Sorry, we're going to practice a little bit of grammar while we're here. So I'm going to say translates down 4 units. What about B? Y equals absolute value of x plus 2. Left 2. Okay, so the plus 2 is in the absolute value. So that puts us into the left-right category, opposite the sign. So plus 2 is going to tell me to go left 2. So I'm going to translate left 2 units. Does that sound familiar from Algebra 2? Yeah. It should. I mean, that was like one of our huge focuses of Algebra 2, wasn't it? We did that on and off all year in various forms. So my Algebra 2 kids right now have just done it with absolute value. They don't realize it's, coming up in parabolas next chapter, and then later on we do it with square root functions, and it just keeps on going. Okay, example 2. This time we're going to be writing equations for these translations. Write the equation for each of the following translations. Shift the graph of y equals x cubed down 3 units. So how do I write the new equation is what it's asking.
Minus the outside of the. How would you say that if it's outside of the absolute value?
Well, let's talk about the issue of why are you putting absolute value in there?
Well, don't I have to?
What is the parent function that we're given?
Oh, I guess that would.
Do you see the point there?
Yeah.
If you're given y equals absolute value x, then yes, put absolute value in. Okay, but we're not given. So this is y equals x cubed. So how do we make y equals x cubed go down 3?
Minus 3.
Minus 3. So we would write this as y equals x cubed minus 3. Easy enough?
For future reference, though, if it were an absolute value and I were to say that, how would I let you know to where the absolute value is? Because, like, I could say open parenthesis, close parenthesis, open bracket, close bracket. How would you say, like,
I'm trying to think of how the absolute value of x, and then you just have to find a way to describe it. I don't know. Yeah. Deal with it when the situation arises. And we may or may not talk about that. But it's kind of, you just have to be careful how you say it. It's more important how you write it at that point.
yeah.
So, okay. Yes.
For that one, I just put x cubed in parentheses. I don't know if that would happen.
Like you put this x cubed right here in parentheses and then minus 3. That would be equivalent. Yep. Okay, B. Shift the graph of y equals x cubed. So again, it's y equals x cubed. This time we're going left 2 units. So, let's see if we can get this. What's your thoughts, Ross?
And I put y equals in parentheses x plus 2 outside of the parentheses cube.
Okay. He put y equals in parentheses x plus 2, and then he put a cubed.
I couldn't exactly remember if the cube still goes on the x.
Yeah, what?
I think it goes on
Am I not allowed to do that?
Yeah, can it go on outside of the parentheses? Because the 2 wouldn't be squared or cubed.
But
Okay.
the result of x plus 2 is cubed.
This parentheses is x cubed.
I'm just looking at C, and it
I
says
put-
x minus 1 cubed, so that's what I put. I put the cube outside.
I put the cubed inside.
So what's the other option that you guys are thinking here?
Y equals parentheses x cubed plus 2.
Like that?
Yeah.
Maybe you can't see it, so you don't know.
I mean, we assume.
Yeah, just like that.
I'm trying to figure out, okay, am I translating what you guys are thinking?
Yeah.
So Ross says the first one I wrote. Some of the rest of you are arguing the second one I wrote.
Is it the same thing?
Are they the same thing? That is the important question. Yes.
I think it's the one that Ross said because he says Ross would just be translated up 2 units instead of to the left 2 units.
Okay, so here's the thing to think about. In each case, what happens if you drop the parentheses off? Is it still the same?
No.
If I drop the parentheses off of Ross's, does that still have the same value if I write x plus, then it would be what, x plus 2 cubed?
Oh, it's a different value.
That's a totally different value because now I no longer even have an x cubed, do I? Okay. What if I drop the parentheses off here?
It's the same thing, you just go up 2 instead of
X cubed plus 2 is still the same thing. Is this 2 truly with the x? And it's not. This right here, what we wrote right here is an up to. Okay? This is our correct version. And what it is, I mean, the idea, if you're going left or right, you have to put the number with the x. Okay? If that means you have to scoot the cubed over, then that's what it means. It would be the same thing as like if it was absolute value. You would scoot the absolute value bar over, right? So it's the same thing. You're kind of thinking, like if you always think that there's always a parentheses around x. Okay? If I put a plus 2 out here, That is different than scooting the parenthesis over and putting my plus 2 in the parenthesis. Okay? Yeah.
Wouldn't that mean that you're also cubing the 2 if you put the thing on outside of the parentheses?
Well, officially, if we were to multiply this out, we would have to do x plus 2 times x plus 2 times x plus 2. But we're not multiplying it out. But yes, the 2, if you were to, when you shift this left 2, yes, there'd end up being a 2 cubed in there. But there'd also end up being an x squared term and an x term. Okay? So, when you have something going left or right, scoot that piece over. So, if your original thing was absolute value x, then you scoot that bar over and put the plus 2 inside of it. Okay? It's kind of the same thing as like the square root of x. Well, if I just say square root of x plus 2 outside of it versus scooting the square root over, so extending it, those are two different things there. Okay, so whenever you're doing that left-right, you kind of have to extend or scoot over or whatever's happening. Have I cleared up the confusion?
No.
Yeah.
Not for me, no, because the cube is like, I still don't get, like, if we're going left 2, I get that the plus makes it the opposite way, so it's left. But the cube, like, if you were to cube 2, now let's say if the parenthesis was just around the 2 and then squared on the outside, then that would be 4 times 2, which would be 8. Then we don't, like, you wouldn't be going left 2 anymore, because then it would be x cubed
But, okay,
plus
this x plus 2 cubed is not, that's not what that equals. Not at all.
But if you're cubing the 2, if that cube is outside of the parentheses, then how is it?
But we're not. We would have to do x plus 2 times x plus 2 times x plus 2. You're not cubing just the 2. You're cubing the whole quantity. Which means that we'd have an x cubed term, an x squared, an x term, and a 2 term. Plug it into your calculator and try the differences. That's a good way to play. Is if you plug in something like x cubed, like if you plug in these different scenarios that we've talked about, that's a good way to kind of play there. But it truly just doesn't work. Okay? I don't think Levi's going to be happy with anything I say here.
No, I already know I got one more.
The x and the 2 have to be together.
Okay, let's try C and see where C takes us. Okay, now C says shift the graph. So y equals x minus 1 cubed. So we're not starting with that same parent graph of y equals x cubed. This time we have y equals x minus 1 cubed. And then we're going to take that graph and we're going to go right 3. So what is this minus 1 in here already doing?
Maybe just
Go right 1. So then we need to, on top of that, go another 3 units right. So what are your thoughts? And I'll clean it up here in a moment. But what are your thoughts of how I'm going to do this? Does that make sense? Okay, so x minus 4 instead of x minus 1, that'd be what I'd go with final answer. Okay, that's my cleaned up version. Now, if you want kind of the step in between, then we already have, if you're putting it with the x, how do we go right 3? We subtract 3. So you can say minus 3, there's already a minus 1, and a cubed. I put that directly with the x, correct? As opposed to putting it outside. As I said, we can clean it up, and that does make it x minus 4 cubed. Okay? Take your calculator and try it on the calculator. I promise that's going to move it. Okay?
I don't get how, like, if you were to just look at the answer, then that would translate that to mean that we're going right 4. What an honor.
It is, yeah. Because it was already right 1.
Don't we need to go right 3?
But you're going right 3 from where you already are. this is our original graph.
Yeah.
If my graph is already right 1, and I move right 3 on top of that, 1 plus 3 is 4. So I have now moved officially right 4. So this was kind of my work step, but this is what it cleans up to be.
Okay.
Did you have the?
Yeah, I know, I get it.
I'm gonna keep. Because we already have
It's just something not quite clicking for
Oh, I got it.
today.
I
So
understand.
you're okay with it now? Okay. Okay. Pay attention where you're putting numbers is what it comes down to, okay? Example 3 takes us into reflections, okay? And right here it's talking about find equations for reflections. So find an equation for the reflection of f of x equals 5x minus 9 over x squared plus 3. We're going to talk about all 3 options here, okay? So I'm going to kind of use lots of space here. I'm going to start by doing the reflection across the x-axis. If I'm doing reflection across the x-axis, what does it say up above? Negative f of x. Which means you take a negative and you multiply the whole equation by a negative. Now, this is a fraction form. So I'm going to put it in front of the fraction right now. So it's a negative of 5x minus 9 over x squared plus 3. It's that negative of that whole fraction. How do we multiply a fraction by a negative? Okay, it goes with the top. Okay. Can it go with the top and the bottom? No. And official general rule of thumb is it should go with the top. The other option is to put it with the bottom. But here's what you don't do. You don't put it with both. If you put it with both, that's multiplying the top by a negative, the bottom by a negative, and negative over a negative is a positive. So you just multiplied by a positive. So as I rewrite this, then if I distribute that negative on top, what does this become? Negative 5x plus 9 still over x squared plus 3. This is an example of a reflection across the x-axis. Let's try it across the y-axis now, if you would. Okay, up in your rules, what's it say about going across the y-axis? F of negative x. And that's coming straight from my rules, right? How does f of negative x work? Yeah. Every time I see x, I replace it with negative x. So on top, it's 5x minus 9. So I'm going to say 5 times negative x minus 9. The denominator is x squared plus 3, so I'm going to say negative x squared, or negative x raised to the second, plus 3. Clean that up for me a little bit. 5 times negative x, negative 5x, minus 9. What's negative x raised to the power of 2? Positive x squared plus 3. Okay, last one. Through the origin. What does through the origin say?
Negative of f negative.
Negative f of negative x. My brain says it combines these. So the negative out front says I'm going to multiply my entire fraction by a negative. The negative in the x says, like what I did last time, every place I see x, make negative x. So 5 times negative x minus 9 over negative x to the second plus 3. I would like to take 2 steps to clean this up. You can do it in 1 step, that's fine. But just leave the negative out front for right now. Don't touch it. How does the inside clean up when I change the x to negative x? Same as last one, right? Valid answer. Negative 5x minus 9 over still x squared plus 3. Correct?
Yes.
Now, how do I deal with that negative out front? Okay, distribute it into peripheral to the numerator, but if the situation presents itself, you could go to the denominator instead. And that's going to be positive 5x plus 9 over x squared plus 3. Yes?
Okay, so stay on a test with homework to solve that. With this negative f negative x, could we just take the f negative x, so we don't have to draw it out again and arrow it over?
Yes.
Put that on.
Yeah, if on the same problem you're having to do all 3, then yes, you could take your previous response and multiply it by a negative, because you would already have that. For the benefit of the notes, I didn't want to skip that step, just, you know, if someone's looking at just the origin one, how do we do that one? Okay. Are we good there? I just realized why I have 2 days of 1-6 in my note, and it might still take us to a second day, but normally we would have had 1-5 homework to check. But we did 1-5 a couple of days ago and then we took a break and did quiz corrections. That's what's throwing me off this year. We might still need a second day, I don't know. But we won't have much left to do if I don't get through it. Okay. Finding stretch and shrinks. Stretches and shrinks. Untied today. Okay, so state the horizontal. It says state the horizontal stretch or shrink affection on f of x equals x squared. Now, I'm going to say we're going to talk about horizontal or vertical. It's going to depend on the situation. Oh my goodness, you can't read that at all. I promise there's a vertical in there, but man, I butchered that massively. Okay. Use your logic skills, you know. Okay, so we're going to state horizontal, basically I want to know, okay, is it a vertical stretch by a factor of 5? Is it a vertical shrink by a factor of 5? A horizontal stretch by a factor of 5, horizontal shrink by a factor of 5. And it's going to vary on the problem. Okay? Some of these will go a little fancier than others. So what are your thoughts about y equals 2x squared? What were those words? Okay. Be more specific and I'll take it. In other words, I always want here, throw in the word either vertical or horizontal. He said stretch by a factor of 2, which I agree with if he throws in the right word in front of it. Okay. Vertical stretch by a factor of 2. Can we agree? The number is out front being multiplied by the 2, yes? It's not in the parentheses. It's not, the key is it's not in the parentheses. So the easiest thing, and we're just going to do the vertical stretch here, is we're going to say vertical stretch by a factor of 2. And I'm happy with that answer. Because to me, when I see a number just multiplying by the front, my brain straight up goes to, oh, it's multiplying, it's going to be a vertical stretch or shrink. What is the number? And we said stretch because 2 is a number greater than 1. Yes. Okay. B.
A vertical stretch by the factor
I think it's a horizontal shrink.
Horizontal view is what
Vertical shrink.
yeah, that's it's still vertical.
it's vertical.
But it's a shrink because the number
It
is
is a
less
shrink.
than 1.
But there is a,
Oh yeah.
so it's not necessarily x squared, it's 0.4 x squared. If that has something to do with it.
So there's 2 different ways we can talk about this one. And we're going to talk about both ways. Okay? As it stands right now, this is 0.4x raised to the power of 2. So if you want to talk vertical on me, which we can do, okay, you have to kind of simplify this out. What is 0.4x raised to the power of 2 rewritten as? 0.4, because when you square this, it's x squared and then 0.4 squared. 4/10 times 4/10 is a 6, point 0.16. So, did I say that wrong? I didn't say 1/4 in there anywhere, did I? My brain thought it got confused. Okay. Okay. So if we do 4/10 times 4/10, and I'm writing this down at the bottom because I want to focus on the horizontal. If you write this equation as such, now what would you describe that as? Okay. Because the number is being multiplied by x squared, this is vertical. Because 1600ths is a number less than 1, it is a shrink. So this, you can, if you'd like, say vertical shrink, and that is by the factor of 0.16. That is a valid answer. I'm not saying that answer is wrong. That is a valid, true answer. There is also a horizontal way we could say this, which I want to talk about how to find that horizontal way, how to see that horizontal way.
0.16 x squared and that one.
If we once we get the horizontal figured out, yes, they would have the same effect. Now, okay, so if you flip back to the front side and you look at the horizontal, with the vertical, it was c times f of x, correct? Going off of memory here.
Yeah.
So a number multiplied by the x squared, vertical stretch or shrink. Now, this one says a number where it's x divided by the number. Okay, technically we don't have x divided by the number, do we? Which is why you guys wanted to go vertical. I get it. However, because this number is in the parentheses, which is how horizontal works, we can think about it. Work with, okay, 0.4. Let me do some conversions here. What is 0.4 as a fraction?
4%.
I lied to you. That's
4/10. 4/10 reduces to 2/5. So is it valid for me to say that this is y equals 2/5 x to the second still? That is an equivalent way to write 0.4 x to the second. I wrote 2/5 x to the second. Now, multiplying by 2/5 is the same as dividing by what number? Multiplying by the fraction 2/5 is the same as dividing by what fraction? No. Multiplying by 2/5 is not equivalent to dividing by 2/5. The reciprocal? Okay, so my point here, I can rewrite this. Multiplying x times 2/5. Multiplying by the reciprocal is the same as dividing. We're reversing division here. Normally we say in order to divide fractions, you multiply by the reciprocal. I'm going backwards. So instead of saying x times 2/5, x divided by 5/2. I'm making an equivalent statement, yes? I'm not doing anything fancy, equivalent statement here. Well, maybe it does appear fancy, but it's an equivalent statement. Based, okay, yeah, it's not pretty, but based on this, now we're in the form to talk about horizontal, because this is x divided by 5/2, or x divided by c. So when we're in the form x divided by c, this is a horizontal what?
Wait, C is still less than
What is my c value? 5/2. What is 5/2? It's higher than 1, because 5/2 is 2.5. And so officially this is a horizontal stretch. And this is by, this time it's by factor 5/2. Now, I think Levi's going to make the point that I need to make. He's saying it had to be a horizontal stretch because we'd already said it was a vertical shrink. Is that where you're going? Yes, and I agree wholeheartedly. Okay. Because think about it, a vertical shrink. You're taking something vertically and pushing it down. As you push something down, what's it doing? It's horizontally getting wider, and thus horizontal stretch.
on a test, will you take it either way, or do you
It would depend on how the directions would stay. So her question was, on a test, would I take it either way? I haven't, I've been getting ready for Algebra 2 quiz. I haven't thought about the test, and I don't remember what I've done in the past to even answer that part. So most likely, unless it specifically says what is the horizontal affection, I would take it either way. Okay. Okay. That is probably a good place to stop, because I have a feeling I would get caught up in the middle of C. And I don't want to get caught up in the middle of C. So, okay, I have more left to do than I thought I did for tomorrow. So, your homework that you can choose to get started on is page 136, 2 through 32 even. Today is Tuesday, tomorrow is Wednesday, so it will be due Thursday. Tomorrow, I will finish the notes, and with any luck, you will have some work time. Sound right? And then I have my plan of, that's Wednesday, finish the notes. Thursday, I'm looking at doing 1.7. And then Friday, I may even be handing out the chapter review worksheet. Okay? If I don't hand it out Friday, we'll be ready to go. That means I'll be finishing 1.7, and we'll be ready to go on Monday. And Stella is throwing lots of stuff at me today. Although last time it was kind of thrown at Maddie, this time it's kind of thrown at me.